Assalamu alaikum wa rahmatullah wa barakatuh. Today we will cover Unit 5 of the course M256, Software Development with Java. Our unit title is Component-Based Software Development. Let's have a look at the unit content and the aims. In this unit, we will start a new trend. We will talk about software quality and cover the concept of components and how they are used in object-oriented software engineering. We will cover the relation between Java and component development, component-based development, and what are the component-related aspects of Java language. And find out how software engineering and object-oriented software engineering components contribute to the quality of software. We will also explain some key issues in the production and use of components. Let us start with software quality and look at some of the main characteristics of software that we consider when we decide whether we are building or we having a quality software. The minimum quality in a software should be at least to deliver the software on time and on budget, means not to exceed the cost, and to deliver a software that can be reliable when carrying its tasks. Some of the very important qualities that you may have in a software are efficiency, portability, testability. Efficiency is defined as how well does the system carry out its task, and that will include making use of its hardware and software resources. Portability, very important feature and implemented very well in Java language, being a portable language. And it means how easy can the system run on different platforms, means different hardware and software. So if you can move the system to run from one operating system to another, from one environment to another, then you can say that our software is highly portable. And testability is just how easy can the software be tested. Being easy to test means we will eliminate many of the errors that may exist in the software. The other very important two qualities that we are going to focus on this chapter and this lecture are maintainability and reusability. And these two qualities are directly related to component-based software development. We can achieve high maintainability and high reusability by developing our software using components. Start with maintainability. Maintainability is very essential quality. And this quality guarantees that our user and our client will be satisfied with the software after delivering it. Because it's very important quality, it's considered as one phase in software development. And you will be surprised that in large-scale software system, maintainability or maintenance cost can exceed the cost of developing the software itself. Maintainability covers tasks required to keep the software in use and to keep the software performing the task to its best. They may include things like fixing emerging problems, fine-tuning the system to improve its performance, and in some situations enhancing the system by adding more features to the system. It's very important to have a software that can be easily maintained, which means a system with high and good maintainability, because the environments are changing, the requirements are changing, so we need a software that can easily accept these changes and can be easily maintained to keep the user and the client satisfied all the time. The other quality is which is very much related to component-based development is reusability. It simply means that we can reuse the artifacts that we build again and again. I can use my code that I wrote before. I can use my design. I can use my ideas that I have used before. And reusability has two aspects. I may build a software using existing component by reusability, or I may build a reusable component to be used in the future. So we have design with reuse and we have design for reuse. When I say design with reuse means I build my software up of existing components, and when I say design for reuse, I design a component that can be reused in the future to be part of some system. Now, as example of reusability in hardware, and that can be a good example for us as software engineers, you may consider the production of cars. You find that they are using or reusing wheels, gearboxes, and so on. And the same wheel can be used on more than one car, which means I can produce a very huge number of wheels that can fit many different types of cars. And it's well known that when you build a big number of components, a massive number of components, then the cost of the production will be very cheap. So reusability will help us producing less expensive software system, and since we build the component once, we test it very well, we tried it very well, and then we produce a big number of that component. So besides being less expensive, it will be well tested. Means we can be sure that the component is reliable, and this is a very important quality. So in summary, reusability can help us building a reusable system and improve the reusability of components. It will be less expensive, and this quality we call it affordability. Means we can afford to build the system with relatively cheap or cheaper components, because it's very well tested, so for sure it will be reliable. If I build a system using reliable components, then the overall system for sure will be reliable components. And the last quality is maintainability. If I have reliable components in the market, maintenance will be easy. I just need to take one component and replace it with another one. All what we said about hardware component development is true for software development and software component based development. So by having these components that are cheap, tested in the market, I can build a component based software, and that component based software is reliable and well defined purpose, or having well defined purpose, and this component based software will sure be maintainable and reusable. One example, for example, in software applications or software based components, software component based development is using, for example, spell checker in word processor. So spell checker as a component can be added to different applications, including word processing. Now let's look at how things are done in software engineering. We have covered earlier objects and classes, and we said that we instantiate objects from the classes, and we can reuse objects again and again. So objects are the smallest object-oriented element that can be reused. Now, objects themselves can't be a component. What we do, we group objects together to build bigger components. These components have the following characteristics. Components are designed and packaged as interacting independent building blocks that may be used in the construction of different products. So we combine and bring together more than one object to build some particular component, and this component needs to be packaged and has some public interface to interact with the rest of the system. These components are constructed from hierarchy of building blocks, which are themselves components. So we are building small components to get bigger components, and maybe two bigger components or three to get a bigger component. They are designed and built to some specifications. We don't build them without any design work. We need to design what the components should include, either smaller components or individual objects, and then we build a new component based on that design. Users and designers of components see them differently. The designers are having some view where the users are having possibly different view for the same component. But that doesn't change the specification of the component. Now, how do we build our components? We are building our components based on a concept in object-oriented technology and object-oriented paradigm called encapsulation. Encapsulation means just packaging, and in its simple or simplest form is packaging the data and operations of a class. So we build a class by packaging its data along with its operations. So the operations will be performed on the data of the class. And when we define the class based on the encapsulation, we should consider the specifications of the class and the implementation of the class. So we need to decide about each method built in the class, and of course the method built in a class or the operation implemented in the class will be invoked on its objects. And the method will represent the protocols of that class. So messages sent to the object will be corresponding to the protocols and methods implemented in that class. Now, when we decide about the specification of the class, we need to code that class. As usual, the attributes of the class will be implemented as variables. The operations of the class will be implemented as methods. And also we need to build some constructors to help us instantiating objects of that class. So everything needed to implement and interact with its objects defined by the class itself. So the class in its specification defines the interaction of its objects, and it will be implemented in some implementation language or programming language. Now this class can be reused again and again, and you can find that clearly with Java language. In Java language, as we mentioned earlier, you have a library of classes, a huge library of classes. Each class has a documentation for its attributes, constructors, methods, how to use these methods. And in the courses M105 and M257, you have used, or I may say here, reused some of Java classes. So you have reused scanner class, you have reused string class, you have reused map class possibly, and many other classes. This is a very simple example of using or reusing Java classes. Now, the class defines the way its objects interacting with the word, and this interaction between different objects is very important to perform the tasks. So I may bring more than one object from Java, for example, and build a bigger component. Each object has its own messages that help that object to cooperate with the word. These objects can collaborate with other objects by exchanging messages. So the object that requests the service is called a client, where the object that receives the message and react upon that message is called the server. All these messages and the protocols are defined in the specification of the class and implemented using the programming language or the object-oriented programming language used to build that component. Another very important concept in object-oriented technology and paradigm, besides encapsulation, is data hiding. Data hiding means objects can hide their data and hide their implementation details from other objects. So if one object wants to interact with the object, the only way of interaction is to send a message. Okay, so sending a message to another object is the only way of communication, means you cannot access the object's details, the object data, only through a permission as a message. So the server object will receive your message and decide what to do with it or how to act as a reaction for this message. This feature and concept of data hiding is the base for the independency of the classes. Means classes are being able to hide their information from the other classes and to keep the integrity of their objects. Data hiding is important because regarding the change in the implementation of the object, its protocol will remain the same. And for the client, even if the object implementation or the class implementation is changed, the client object will continue to use the same message and the same protocol. The other thing is that, and this is a good feature for the server object, is that the object will keep its integrity, and that's its object's state. not affected by the interaction with other object because it's protected by data hiding. So object state is controlled by this feature. As you can see in this diagram, you find the messages are sent to the protocols where the workings are hidden within the class. So the integrity of data is kept and the data itself is protected. The only way to communicate with any object is to communicate through its protocols, and its protocols should be built in a way that protect and control the access for its data and implementation details. Now, when we are building objects, we define the states of these objects. And the state of these objects is made up of other data in the system. In Java, this can be either another object or other objects in Java or primitive data types. So I may build, for example, a class student. In that class, I have the object student. Object student has name and has age. Name as attribute in the class student can be of type string, so it's of type object in Java language. And that object is an object of type string, where, for example, age is of type integer, and integer is a primitive type. So the states and attributes in the Java class can be either made up of other objects in Java or some primitive data types in Java. Each object referenced may itself refer other data. So, for example, if I have a name as a class, then my first name will be one string, second name another string, and last name is a third string. So I'm having an object as a reference of type name, but its components are other reference data types of type string. So the state of each object can therefore be viewed as a tree-like structure of either objects or primitive data types. Please have a look at exercise 2, which gives you another example on the tree-like structure of objects state. Figure 3 here gives us example. Look at the customer ID as a state in object order 1. You find it built of array, and that array is built of a primitive data type character. So the customer ID is an object built of primitive data types. Not only this, order as an object has another object in it, which is product, and that product is built again of two primitive data types, product number and unit cost, and also it includes an object array. So this is the hierarchy we are talking about. Array 2 is part of a product 23. Object product 123, including its array 2, is part of object order 1, which includes another object of type array and a primitive. So order 1 has an object or two objects, array 1 and product 23, and a primitive. Product 13 in its turn is having two primitives and another object of type array, and the array itself is built up of characters. Now when we are building classes, as we mentioned earlier, we build them based on some design and specifications, and this should include the protocols of the class, means how it should be interacted with in its environment, what components are needed to build this class, and what are or is the result of interacting with this class. All this should be considered when we are building our class. And if we are building a class to be reused, all this should be clear to the client object. Make it clear of how your class is to be interacted with. Make it clear of what results of interacting with my class objects will give back for the client. So far we discussed very important concepts in software engineering, and particularly in object-oriented software technology and engineering. We discussed encapsulation and information hiding. A related and third concept is polymorphism. Polymorphism is the capability for objects of different classes to respond to the same message in a manner appropriate for each object. And I'm sure you have covered that in previous Java courses. For example, if I have a shape as superclass and square and circle as subclasses, when I say calculate area, the square will calculate the area using a formula different from the one that will be used in the circle. And that's what we mean by polymorphism. This is a very important feature that will enable us to replace a component by another if both are meeting the same specifications. Now we elaborate more on the perspectives of user and developer considering classes. The definition of a class itself is distinct into two parts: the specification of the protocol and the detailed implementation. The client is concerned only about how to interact with the class, which means they are concerned only with the protocols, where the developers are concerned with the implementation and how to make this class working and responding correctly to its clients. So they are more of concerned with the implementation. And that's why we say that the user of the class are having different perspectives from the developers of that class. Now let's look at some of the component aspects and components features that you can find in Java. Basically, the main component in Java is the package, and the package is a kind of mechanism that Java will use to group its classes form an object-oriented software component. In many situations, it's important for a class to get the help from other classes to be able to cooperate and perform. And this means that the class should be linked to some other classes or depend on some other classes. In Java, there are several ways in which class can depend on another class. If we say that we have class A and class B, then ways of dependency between these classes can be either class A is subclass of class B, means class B is superclass for class A, or class A objects may need help from class B objects. So inside the class A methods, a message may be sent to class B objects for some service. The third case is class A may have a method that receives or returns class B object. So class B object is a parameter in one or more of the class A methods, or returned by one or more of the class A methods. The fourth case is class A may define instance variable reference of class B, means one of the states or the attributes of a class A is an object of a class B. If the classes are related, then one good choice in Java is to have them in one package, and considering the whole package as a component designed for reuse or designed with reuse. Now, when classes cooperate and collaborate, they cannot allow other classes to control or to access all their members. What do we mean by class members? Means the elements of the class definition, such as their instance variable and methods and constructors. So classes need to hide totally or partially their members from other classes that they cooperate with. Here is an example of class account, and in this code you find that the members, and particularly in this case the balance attribute, is accessed directly from other objects, and this is what we are trying to avoid using what we call access specifiers. So in access specifiers, or sometimes we call them access modifiers, we hide class members, which means class attributes, class methods, class constructors from other classes. And this hiding of information has different levels. We have public access modifier, we have private, and we have protected. And in Java we have some special access modifier or access specifier, we call it package, which is a default access modifier. Means if I don't specify my access modifier for class members, then it will automatically be defined as package modifier. In case of public, any class in the package or in any package can access the public member. When it's protected, The class itself can access it. All classes in the same package can access it, and any subclass outside the package can access the protected member. Where a very special case, the private member will be accessed only by the class itself. And the last specifier in Java is the package specifier, means when the member is defined as package specifier, and that will be by default without labeling it with package, it will be accessed only by classes in the same package. It's common policy for software developers, and particularly Java programmers and developers, to start by defining all instance variables as private. This will secure the variables, and if needed later, they can change from private to public or protected or package as the class design specifies. This allows the developer to keep the integrity of the class, means client outside the class cannot access the internal implementation details, and clients will not be concerned with the implementation, they will just concern with the protocol, and that protocol is not changing in all cases. The state of the object cannot be accessed, and that will keep the integrity of the data of the object. And the only way to interact with the object is to call or invoke the methods of the objects by sending corresponding messages. This will guarantee hiding the information and maintaining high integrity of data. In this figure, you see that packages is used, and you find objects of different classes are packaged together in one package, and if another outsider object is trying to access, it will go through one of the objects, and that object will represent the whole package to the outside world. Now, when we are building packages, we have to use the right modifiers to allow the interactions with the package to be in control. This will allow objects of classes within the package to interact with the real world and provide their services appropriately. This will allow the clients to interact with the package and get their services from that package. This will protect the package from changing through client access, and the overall integrity of the whole package will be maintained and protecting during being used by its clients. Now, when we say integrity of package, we mean the consistency of the states of the objects in that package. And this can guarantee by introducing a term very important from now on. We call it the coordinating objects. The coordinating object is a core system object through which the user interface accesses the services of the core system. So instead of going directly and access the core system objects, the interface will go through some particular defined object for this purpose called coordinating object. In figure 10, we illustrate the interaction between the user interface and core system objects, especially when using the coordinating object. This kind of interaction between the interface and the core system objects can be outlined as follows. The user interface, in this case the object on the left side of the diagram, sends a message to the coordinating object, which is already within the core system. The message will be requesting the core system service. The coordinating object coordinates the services provided by the objects in the core system to provide the service requested by the user interface. In this way, the integrity of the core system is better preserved. If the user interface communicates with the core system via coordinating object. There is an exception for this case when the user interface cooperates with the objects using getter messages, for example. If the client of the object can access and improperly manipulate the state of the object, then we use the term privacy leaks or privacy leak to describe this situation. Client object is being able to access and manipulate the state of the object without going through the protocol or the protocols of the class. This will put the class in a risk and will destroy the integrity of the data of the class. There is always danger when we are dealing with instance variable that reference mutable objects. Mutable objects are objects whose state can be changed. So if we have a privacy leak, considering one of the variables of the object that are mutable, then the danger of changing this variable is there. On the other hand, we have what we call immutable objects whose state cannot be changed, and they will always be safe when we consider privacy leaks. To solve this problem, we can create what we call a defensive copy of the mutable object, which is a distinct object with the same state. This is made clear in this diagram, where we have the original object and the defensive copy that to be accessed by the client. So by having this copy of collection, copy 2, or collection 2 from collection 1, copy of collection 1, then the client can access this object, and by this we can be sure that our original collection 1 object is protected. Now we move to a very important part of the unit, which is using and producing components. As we mentioned earlier, components are the base for achieving high qualities such as reusability and maintainability. And in component-based approach, we have two aspects to consider. The first is what we call design with reuse, means we are using existing components when creating a piece of software. So on the shelf, in the market, there are some components that can be reused. So we use them to build our software. Where on the other hand, and the other aspect of component-based approach is design for reuse. Means we produce component carefully and work on making these components easy to reuse by others. So other people will reuse these components to build their software. So design with reuse and design for reuse. Design with reuse, we have two alternatives when you design them. We may reuse by inheritance, means taking the component or the class as superclass for us and use its behaviors and attributes. Or reuse by composition, making the object of the class part of our object. And use it to enlarge our components. Here are more examples of how we use components using composition method and the advantages of this use. Now come to design for reuse. When we designing our components for reuse, we need to build them carefully, and we need to consider two main aspects or two main characteristics in these components. The components must have high cohesion, and cohesion is the measure of how strongly related and focused the responsibilities of a component. So high cohesion is considered desirable. A component with low cohesion defines unrelated responsibilities and is not very useful when we are talking about component-based development. So build your component to be high cohesion. Component with low cohesion is hard to use, hard to understand, and hard to test. The other feature that you think should have is to have a low coupling component. Coupling is the measure of the extent to which component is dependent on other components. So try to build a component that doesn't depend much on other components. Of course, it cannot be isolated from other components, but not to depend on other components totally. So what is desirable here is to have low coupling component. When it's high coupled, it may need to include many other components within the design and make it harder to reuse. Again, they are hard to understand, hard to test, and hard to maintain. These two aspects of component-based development, design for reuse and design with reuse, are very important. Please study them carefully. They are good material for questions in the exams. This is the end of Unit 5. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.